Right, good morning. Welcome to another exciting topic, a very interesting topic, a topic that is also normally dreaded by so many learners. So many learners are scared of electricity. I'm not sure whether it's because electricity in reality it's dangerous, so maybe they think that electricity even on paper is also dangerous. Right, so I'll just unpack this question here so that every learner can have a better understanding of the topic. Right, the most challenging thing in electricity is the approach. You must have the correct approach to the question. If you don't approach it correctly, then you will never understand it. Right, so I'm going to unpack how you analyze the circuit diagram. Just like in English, if you don't understand a passage, there is no way you can answer the comprehension questions. So our problem with learners, they just go straight to the questions without looking at the diagram. Right, so let me take you through the diagram. This is a combination of parallel and series circuit. We have two resistors connected in parallel here and one in series. Right. When switch S is open, the voltmeter reads 20 volts. This is the 20, the voltmeter that reads 20 volts. A voltmeter connected across the battery. When a voltmeter is connected across the battery and there is no current flowing in the circuit, the voltmeter reading will be the EMF. So this is actually an indirect way of the examiner giving us the EMF. So our EMF there is equal to 20 volts. At times you might be very fortunate that the examiner just tells you that EMF is 20 volts, but in this case it's given in an indirect way. Okay? Right, so that is our EMF. Now, there's also information that is given that when the switch is closed, the emitter reads 1.62 amperes. So the 1.62 amperes will be the total amount of current flowing in the circuit, because at this point, current is not being divided. It is only divided when it gets to this point. So the 1.62 will be the total amount of current flowing in the circuit. Right, like I always tell learners, look for a point that has got two quantities, then you calculate the third quantity. So we are going to look for such a point that has got two quantities and look for a third quantity. From this point right up to this point, the amount of current flowing remains 1.62, 1.62 that I've written here. So it means in the battery, we have the internal resistance and the amount of current flowing. So with those two quantities, we can calculate the V internal, which is the voltage being used by the internal resistor. This is the formula for calculating the internal current, the total amount of current multiplied by the internal resistance. So the current is 1.62 multiplied by 1, which gives us 1.62 volts. That is the internal voltage. Right. We also have another formula for calculating EMF. EMF